So this section is from chapter 2-2 and is on graphs of functions. So in the previous section we looked at the graph of 2x minus 3y equals 15. And so this graph can actually be more easily plotted if we get one variable in terms of the other one. So usually and then in this case we would want y in terms of x. So we want to get this equation to some y equals some x equation. So to do that we need to first subtract 2x from both sides. So we'll have negative 3y equals negative 2x plus 15. Oops. Then dividing by negative 3, we get y equals positive 2/3 x minus 5. From this point, we can plug in any particular value of x and get the corresponding value of y. And for that reason, it's much easier to graph. So we're going to plug in values of the independent variable and get a value of the dependent variable. In this case, the independent variable would be x because, and y would be the dependent variable because you're going to be plugging in any value of x and y is going to be dependent on what value of x you plug in. And so you're going to plot the independent variable on the horizontal axis and the dependent variable on the vertical axis. So many functions have graphs that aren't just straight lines but are instead curves. So this is going to be an example of that type. So to graph this function, we're going to need to plug in values of x and get the corresponding y value and then graph those ordered pairs. So let's say we plugged in negative 5 for x. You would plug in negative 5 wherever you see x. You would get negative or 0.2 times negative 5 squared. And that's going to equal positive 5. So you would continue doing this for different values of x. So if we plug in negative 4, you end up getting 3.2. And negative 3, we'll get 1.8. If we plugged in negative 1, we would get 0.2. 0 would get a 0. 1 yields positive 0.2 again. 3 would yield 1.8. And 5 will get us positive 5. Notice that this is a graph of a parabola and there is symmetry on both sides. As you can see, as x is negative, you'll be getting positive values of y, and we'll get those same values of y for the positive x value. So graphing this equation, we start by just drawing the axes. So this would be the vertical and this would be the horizontal axes. Labeling this x and y. And at this point, we can just plot these values of x. So if we're counting 1, 2, 3, 4, 5, that will get us 1, 2, 3, 4, 5. So we'll plot that ordinate pair there. Negative 5 will also give positive 5, so we count 1, 2, 3, 4, 5. We can plot this point right here. At negative 4 gives 3.2, 1, 2, 3, puts about here. And positive 4, since it has symmetry, would also give 3.2. 1, 2, 3, 4. 3.2, it's about there. 0 would yield 0. And at that point, we can just draw a smooth curve connecting these points. That's not the best curve. Let me try that again. So we will draw a smooth curve connecting these points. A bit better. So notice again that there is symmetry across the y-axis in that if you drew a vertical line right here at x equals 0, then we're going to have symmetry on both sides. So that's why this is called the axis of symmetry. So now sometimes you can't just plug in any value of x into a particular function. So for that reason we have what's called the domain. So the domain of a function is the set of values of the independent variable. So that's basically what any value of the independent variable could be. So usually x. It's whatever you can plug in for x. So for example, if you have the function y equals 1 divided by x minus 2, then we can't just plug in any value of x, because if you plugged in positive 2 for x, we would get y equals 1 over 2 minus 2, which equals 1 over 0, which is undefined. So for that reason, we say that the domain is x can be all real numbers. That's the two lines with the r is the symbol for reals, but x cannot equal positive 2. So the range of a function is the set of values of the dependent variable corresponding to all values of the independent variable in the domain. So what that means is whatever the domain is, the range would be the set of values that the y could have, like, corresponding to that domain. So a good way to show this can be in like a picture. So let's say we have the function some function like this, okay? And we're going to say that these are the endpoints. So the domain of this function would be the set of x values that it can be. So that would be from about there to there. So we're going to call that domain. Now the range, on the other hand, is the set of y values that this function can be. So that would be from this endpoint to this endpoint in the y direction. So for this function, we're going to plot this graph within the indicated domain. So the domain here is integers from 1 to 6, and we're going to say that's inclusive. So to start, we're going to make a table of x and y. So we're going to have x here and y over here. So we want integers from 1 to 6. So if we plug in 1, we get 10. If we plug in 2, we get 5. 3 will get us 10 thirds, or 3 1/3. 4 would get us 10 divided by 4, which is 2 1/2. 5 would get us 2. And 6 would be 10 divided by 6, which is 1 2/3. So the range of this function would be all the y values that are yielded from this given domain. So since the range is only these values and not values between 1 and 2, since it's only integers, we see that the range would be 10, 5, 3 1/3, 2 1/2, 2, and 1 2/3. And then plotting this graph, we would start with just drawing the vertical and horizontal axes and labeling them x and y. And we would start by just saying, here's 1, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here would be the first value. 2 would be 1, 2, 3, 4, 5. 3 gives us 3 1/3, 1, 2, 3, it's about here. 4 gives 2 1/2, it's about right there. 5, just 2. And 6 is 1 2/3. So now notice that this function, we would not connect these dots because the domain and range are only particular values. We can show the general pattern just with the dotted line connecting the curve, but the dotted line is not a part of the graph. So the problems for this section involve graphing functions when given a particular function and the domain. And so the main thing that you want, like the best strategy to do here is to make a table of values of x and y just following the indicated domain. And yeah, that's about it.